I have made him the co-host. He can even share the thing.
Okay, okay. Thank you, ma'am. A very good afternoon to one and all present here. So I hope every one of you have connected us again. And we will start now our next session of today's international webinar with the theme Transforming Global Health on this auspicious occasion of World Pharmacists Day. So thank you once again, all of you, for joining us. Now, I would request Mrs. Chainika Bordoloi, Assistant Professor, NEF College of Pharmacy, Guwahati, to please help us in introducing Dr. Ramalingam Sir, Professor and Director, R&D Division, Ragavendra Institute of Pharmaceutical Education and Research, Andhra Pradesh, India, through her introductory speech. Chainika, ma'am.
Thank you, ma'am. Am I audible, ma'am?
Yes, ma'am, you are audible.
Thank you. So, Dr. P. Ramalingam sir has completed his B.Pharm in RVS College of Pharmaceutical Sciences, Coimbatore, and M.Pharm from Sri Ramakrishna Institute of Paramedical Sciences, Coimbatore. Then he submitted and as lecturer in Bapatla College of Pharmacy, Andhra Pradesh, joined as assistant professor in College of Pharmacy, Gulf Medical University, UAE. Then he joined as associate professor and head of department of pharmaceutical chemistry and analysis in Ragavendra Institute of Pharmaceutical Education and Research, Andhra Pradesh. Then currently he is working as professor and director cum research supervisor of RIPER, Andhra Pradesh. He achieved so many awards like BIRAC awards, Best Teacher awards, etc. etc. He has completed 2 industrial consultancy projects, and under him now 6 ongoing research projects are there. He has 3 authored books and nearly 100 research publications. He is involving with many government recognized committees as member and nominee. He has attended nearly 20 numbers of national and international conferences, and he is a approved question setter and evaluator of many universities. Heartiest welcome to sir. Over to you, sir.
Thank you for your nice introduction. It's nice to hear from you all. And could you please share my slides? Yeah, please.
Yes. Sir,
And
you are a co-host.
Please, yeah.
Sir, you are a co-host. You
yeah,
can
actually, me, and I think, could you please help me out to share my PPT, okay? Wait.
Sir, you can just
share. Yeah, it is there with the principal. I have sent to them. If possible, can you share it? So it will be convenient for me.
Yes, sir. Yes, sir. Please hold on, sir.
Yeah, because I'm doing the mobile here, and so if you could able to share the slide, it will be convenient.
Okay, sir. Okay, sir. Please hold on, sir.
Okay. Yeah. Because don't mind, just now I come from meeting because that
yes, sir,
file is not
understand.
there in the mobile. That's why.
Yes, sir. We can understand,
yes,
sir. Please hold on. Your slides will be presented. So I request participants to please be patient. We are preparing, the slides are ready.
And
Yes.
excuse me.
Yes, sir.
Yeah. Meantime, I can speak something with you people. So okay,
Yes,
you
sir.
can make it ready.
Yes, sir. Yes, sir. You can share your ideas, sir, your thoughts on this great day.
Yes. So without wasting time, I can write
Yes.
please, can you remove the co-host so that the admit.
Yes, sir. Sir, you are the co-host. Sir, you can please speak. Yes, sir.
Oh, sorry. So good afternoon and good afternoon, everyone. And it's my pleasure to be here on this platform. And so really, I thank your principal, Devapratim Das Gupta, and your college, the NEF, and all the organizing committee members, and for organizing such a wonderful virtual international seminar. Really, it's the topic is wonderful, like transforming the global health, and I feel it's a need of the hour. Really speaking, it's a need of the hour. It's very essential as on today, because the things what was going on today and earlier, and it was totally different. It was something like it become traditional, and whatever the strategy, whatever the technology, whatever the the practices we have done to save our human health and prosperity or wealth of the society is should be totally different from hereafter, because the that exactly the pandemic is a big lesson for us, that and really we are inadequate to face the challenge in future. And dear budding pharmacists and a participant of this international webinar, and before I start my speech, I would like to say one thing. I just a warning to you people all, nothing but. And in the recent edition, I have published one paper. It's on the need for enhancing the antiviral research in India, and that shows it's a kind of there are 43 viruses still away from our knowledge, and the one among the 43 virus, the COVID-19, this whatever the SARS-2 virus is one among the virus. So this COVID pandemic situation, it's not going to be end. It's not an end point. And I feel if at all, if you don't take any necessary measures, and we have to change our lifestyle, and we have to change our mindset, we have to change our health practices, we have to change our hygiene conditions, we have to change our protective measures to prevent. And another 43 more out of 43, there are still 18 more viruses are there in front of us, and which may cause the pandemic once again. But it's very pathetic, and it's it's unfortunate. You might have listened the statement from the WHO chief, and 2 days ago he made a statement that though this COVID pandemic is going on, and there are plenty of antiviral vaccines are under development at different parts of the world and globe, but still the WHO is not optimistic. I mean, the WHO is not confident that this whichever may be the viral vaccines under development will be successful. And really, it is tough time for everyone, and every one of us, and the present generation as well as the future generations. And really, it's a big battle. It's a kind of war between mankind, and the organisms. No, one thing I just wanted to share you there. It's very interesting, And if you see this infectious disease, as the size of the organisms go smaller, that become more dangerous. Very simple example, you see, you take amoebiasis. Amoebiasis, that is whatever the causative organism, it is bigger than bacteria. So that it is very easy to treat. The bacteria is smaller than amoeba. So here what's happening is the bacterial diseases are more dangerous than amoebiasis as well as fungal infections. If you take virus, it's maybe RNA or DNA. It is very, very the smaller and the smallest organism when compared to bacteria. So now the virus become the more dangerous than bacteria. And that's what here, if you see, as the size and the diameter of the organism is coming down, like amoeba to, there is amoeba to fungus, fungus to bacteria, bacteria to virus, it's becoming very dangerous. So really, it's unfortunate to say. And I just before start my presentation and stay safe, take all protective measures. Not only now, you get mentally prepared for not few more months. It is maybe another 1 or 2 more years. It is very, very essential. And what's going to exactly happen the next 2020, how the things will be there, and what are the things, it is still, and we have to wait and see, and we cannot predict. And we are obviously with all our scientists effort, and we should feel that we ought to be very optimistic, and whatever the vaccines are under development now, and at least one should become very successful one to save our humankind and mankind from the pandemic COVID-19. And at this juncture, I congratulate all the participants. I can see many students are involving very interestingly. Really, I am impressed with your students and team and faculty members of your college under the leadership of a principal, that you come out with the international seminar and this transforming global health. So today, for half an hour, I'll be enlightening some key component of pharmaceutical research and challenges. And if the presentation is ready, please, can you share? Is my presentation ready?
Yes, sir, the presentation is ready.
Please, the admin, okay. Please, admin, you can in setting and you can admit all. You can change the thing because it's showing notification that admit. Yes. Saurabh, enter the waiting room. You can remove the waiting room, please.
So we are going to share
Please
your screen.
clear the waiting room. Clear the waiting room.
Yes, sir. It is cleared, sir.
The screen is visible.
And Miss Arundhati.
Yes, sir.
Hello. Miss
Yes, sir.
Arundhati, please in the setting you just
Yes.
change that. There is a notification coming that waiting room.
Yes, yes, sir. Okay, we'll clear that, sir.
Okay, you just clear the waiting room or you just allow everyone? Yes. You can go for slideshow. Please, you can go for slideshow. Yes. Yes. Waiting room, 1 second, there is a problem. Setting. Meeting setting. Waiting room. Long waiting. Okay. It's fine. I remove the waiting room. Yes. Very good afternoon and all the delegates. And I'm here to present the topic what I am going to talk to you for next half an hour. Will be like, pharmaceutical research, opportunities and challenges in drug discovery. Please, next slide, please. Yes, hello. Am I audible, please?
Next slide.
Am I audible?
Next slide.
Yes, sir.
Okay. Yeah. So the slide shows the topic what I'm going to discuss. This is pharmaceutical research and opportunities and challenges. So here, it's a kind of slide which I prepared and to made it for especially teachers as well as the academic people. As in today, if you take academicians, the biggest task for the academicians are a lot of challenges. I mean, if you take academicians, one, you need to do administrative work, and you need to do external affairs, and you need to teach the students. You need to do a lot of documentation work, and there are a lot of self-appraisal, and a teacher himself has to prove a lot of ability to the management. But here, for a student, you being a budding pharmacist, and you may ask a question, sir, what is my research? Where I have to start my research? What is the proof of research I can show to the world? See, this is the order of your research where you can enter. Remember, always you start with your research publications. And being a B.Pharm students, or your PharmD students, or M.Pharm students, you start with your publications, research paper publications. And the publication may be a research publication or review publications. Obviously, if you have done your B.Pharm project, you can publish your B.Pharm project in your publication. That is the starting point of your research. Or you present your paper in your conferences and you interact. You talk your research to your major community. You discuss with the people. You gain your knowledge. So the research is the one which you cannot get it from paper or cinema or TV or YouTube or Google. The research is the one that you can get only when you interact with the people, when you share your knowledge in the community. There is a way to develop your research. Don't think that you have your mobile, you can see your YouTube, you can see your Facebook, you can see your WhatsApp. That is not going to help you to develop your research. The research is the one, it comes only from the dialogue, not from monologue. Next slide, please. Next slide. Next slide.
Yes, sir. Changed, sir.
Yes. There are a lot of limitations for the academician, especially in Indian setup. In students or academicians, number one, we are lacking interaction outside the world. So I appreciate and congratulate your management or your principal that this is one of the interactions. See, you people, you students are sitting at Assam, you are interacting with me, with a speaker like me who's from Andhra Pradesh. Exactly, this is the one of the interaction which is highly required for you students. One is the lack of interaction out of this world. Second, more commonly, in academia, the students or teacher, they lack access to the potential researchers from central laboratories and international universities. Next is, we are lacking a lot of research space workload. Many cases, what happened? The students are forced to filled with complete syllabus, day and night, syllabus, morning to evening, theory, practical. Students are not having enough time to think about research. The students are not having time to not even talk about research, to understand. Even many students, they don't understand what is research. The same way faculty members are the same case. Many of the faculty are loaded with the teaching. They don't have enough time to talk about research. Next, lack of motivations. Many students, many institutions, they don't have the policy to motivate the students or faculty towards research. It is a very essential. It's very essential that a student or faculty should get motivated from the superior. And in my view, the students should get motivated from the teachers. In the classroom, teachers should talk about research at least for 5 minutes per a week. The same way, in a meeting, a principal should talk about research to the faculty member. The same way, the management member should talk about research with the principal. It is very essential in this world. The same way, and the industry, the academic institution should have partnership with the industries, so that the student and faculty will come to know exactly what is going on in industry. And apart from that, the institution should come forward to provide financial support. I'm not saying you pay lakhs and lakhs to faculty member. You pay some thousands to faculty member so that they can purchase their own chemical and they can do research. Another case, and the adequate facilities should be there. But last but not least, I wanted to say, in my view, only 10% of the students or 10% of the faculties are really interested in research. So here, your students, your principal, and you are supposed to motivate the faculty, motivate the students to inculcate the research interest among students. Because I'll tell you, I am sure the future world, if you are going to save your world, if you want to save the world from the COVID pandemic, the research attitude has to be there in the present student and faculty. So only the research going to serve future world. Next slide, please. Yes. You know, if we go for Government of India, it is already mentioned. It is not the whatever the slide I projected. It is not my own slide. This is a slide copied from the Government of India website. Around 4 years ago, in 2016 itself, the Government of India is motivated the pharma industry to initiate research. It is very essential. Is motivated the pharma industry to motivate the research. I'll tell you, in entire sector, we have IT sector, agriculture sector, education sector, pharma sector. The richest sector, pharmaceutical sector, who can do wonderful research. But unfortunately, if we take pharma companies, our Indian pharma sector, they are more about the business oriented. They are not research oriented. The reason is, if a pharma companies, if it is business oriented, they get a lot of income. If it is research oriented, they have to invest a lot. The same thing is there near many pharmaceutical institutions and colleges. Because if at all, if any institution want to inculcate or develop research, they need a lot of budget. So it is very essential at management level or principal level, they have to come forward, they have to invest money in the budget in the institution to develop a research facility. And it doesn't matter that the management has to be convinced in such a way that they should dedicate that 10% profit to research. It is very, very essential in the today's pandemic. Then only you will grow, your teacher will grow, your institution will grow, and finally the country will grow and country will be safe and in future. Next slide, please. Yes. And dear students, spectators, this slide is very, very interesting. You please go through the slide, what I have written here. Do you know how many diseases are there in the human? It is surprising for you. 1 lakh human diseases have been identified so far. Out of 1 lakh human diseases, 7,000 diseases are recognized as rare diseases. Out of 700 diseases, only 400 diseases have licensed treatment. It means there are about 6,600 diseases where we don't have treatment, we don't have drug. So here the slides convey a message that at this current rate of drug development, so definitely it takes another 500 years to get treatment for all these conditions. It means if you are a researcher, if you are a scientist, you will be evergreen, you will be most respected in next 500 years. That's what I want to say. Next slide, please. So I was telling that, you know, the out of all sectors in India, only the pharmaceutical sector is the richest sector. You just please go to the slide. You can see the enormous growth of the Indian pharma companies. And it is the revenue generated by the Indian pharma company. You can see that in India in 2020, it is expected that the revenue is $55 billion. In 2005, it is just $6 billion. In $6 billion in 2005, it has grown up to $55 billion in India. So that's what I'm saying, that Indian pharma company, they are nowhere less. They can invest like anything in developing drug. They can invest in drug discovery. They can invest in drug discovery, new molecules. So this is what I just said. It is the information copied from the Government of India website. Please, next. Yes, for you student, I just want to enlighten. What are the deadly diseases which are need new drugs? Let us classify this disease into two categories. One is infectious, another is non-infectious disease. Remember, under infectious disease, there is smallpox, and there is a black plagues, tuberculosis, malaria, Ebola, cholera. Right now, it is COVID, viral diseases. So these are the various infectious diseases. It is ahead front of us, which are threatening us. And after that, you can see, I just wanted to introduce a word. It is a drug resistance. It is going to be most challenge. You know, right now you're going to hospital. Doctors are writing prescriptions. Are you sure that the antibiotics are effective on your disease? No, never. So here, one of the major concern with the infectious disease are drug resistance. Do you know whatever the antibiotics which are available as on today, almost 60% of the antibiotics are ineffective now. The remaining 40% of the antibiotics is going to be ineffective in next 10 years. So I mean, by 2030, definitely there will be by 2030, and whatever the antibiotics available in the market, it's going to be completely ineffective. And next is when you go for non-infectious disease, The heart disease is a continuing problem. And when you go for your human cancer and respiratory diseases and cerebrovascular diseases, Alzheimer's diseases, and diabetic, and they're all challenging here. See, and for infectious disease, we require new drug molecule. When it comes for non-infectious disease, it is very, very essential. One, we should focus on milestone research. The milestone research is the need of the hour today. Next slide, please. So students, as I come to know that most of the audience are the students, I just wanted to say what is research. I don't think that the research is something a big problem. Research is not a problem, it is a problem solving approach. The research is not something learning from textbook, it is not learning from newspapers, it is not listening from somebody else. It is something people are nothing but we are taking mobile and searching something in Google. It is not research. So exactly the research is the one that we try to understand what exactly in the world. The research is the one what we try to solve the problem. Exactly what I'm saying is the COVID pandemic 19 is the problem. If you think something to something to solve this COVID pandemic, that is the research. And if you try to improve the existing solution, the best example, curcumin, turmeric. The bioavailability of the turmeric, even though the turmeric is having antiviral property, if you try to solve this bioavailability problem of curcumin, that is also going to be it's a research. It is one of the major challenge now. It is very difficult to enhance the curcumin bioavailability. So, curcumin has a lot of property: anti-malarial, antiviral, antibacterial, anti-diabetic, intestinal, antiseptic. There are so much property for curcumin and turmeric. So one, if you're able to improve the bioavailability, right now in the current research, people are trying to do some attempt on converting your curcumin into nano formulation, nano suspension, even nano ocular delivery also they're trying. So if you are trying to improve the existing solution, also is coming under research. Next slide, please. Yes. There are different types of research. Sometimes the research can be a primary or secondary, or sometimes the research can be qualitative or quantitative. Sometimes the research can be exploratory, descriptive, or conclusive. So here the types of research are primary, secondary, or qualitative or quantitative, or exploratory or descriptive. That is called as the different types of research. In pharmacy, especially, the research are maybe either exploratory, descriptive, or conclusive. Our research can be a pharmacy student, being a B Pharm or M Pharm. You can take up any research, either exploratory or descriptive or conclusive research. That's what. So, best example, in case of exploratory, for example, you have a plant in your region, and you are trying to explore the plant, what is present it, and what exactly it, where it can act, whether the plant possesses antibacterial, antifungal, anti-tubercular, anti-cancer. You are trying to explore the knowledge of the plant into the science. That's called as exploratory. Descriptory, you do something and you describe, okay, so and so. It's called as descriptive. Conclusive, very simple. And after doing your explorative description, you say, okay, this plant is having anti-cancer property, or this plant is do not possess anti-cancer. Such a way you try to conclude it. It's called as conclusive research. Next slide, please. Next slide. The research process in the next slide, please. Next slide. This is not visible. Next slide. Next slide. Yes. So what are the various components of the research design? If you're going to do your research, the first problem is nothing but, as I told you, the research is focused on identifying a problem. So being a student, I just want to focus on this aspect, how you are going to identify a research problem. Once if you are going to identify a research problem, then you try to outline, then you try to solve the problem. So in case of your research problem, and you just outline your area of your interest, whether you are interested in infectious disease or whether you're interested in non-infectious disease or diabetic or cancer or tuberculosis or bacterial infections. Then the research you try to choose a topic. Out of all the topic, you choose in your topic. Okay, I just wanted for infectious diseases your interest. I wanted to choose antibacterial. Then antibacterial, once again narrow your topic. Like which bacteria you wanted to focus. You want to focus on your mycobacterium, or you want to focus on gram negative. You wanted to focus on gram positive. Then in a case, already there are a lot of antibacterial agents are available. Already anti-tubercular agents available. Already cancer available. What is the problem? Why you want to go for new antibacterial agent? Why you want to go for new cancer agent? That is your research problem. Then once you identify a problem, then you define your purpose of study, then you go. Here, student, you just see, out of all, in identifying a research problem, choosing a topic is very, very important. But here, many B.Pharm student, final student, just we talk a topic and we do a project. It is not the case. See, before choosing a topic, you have to observe your environment, what is going on, what is current trend, and you just be curious in the news, curious in the journal, curious on update. Ask so many questions to us, like us. When a speaker, you got a speaker, you ask so many questions. And read about your interest, you talk to your colleagues, and you interact. You have to do lot of interaction, lot of study on your topic before you finalize a research problem. Otherwise, your research will become a repetitive experiment. Next slide, please. 1 minute. Yes. Yes. Here, I just wanted to give a kind of, for the student, what is research question and hypothesis? Many of us, many students at level who's doing research, they don't have a difference. They don't know the difference between the research questions and hypothesis. See, generally, here the slides, you just go through that. It speaks about what is research questions and hypothesis, because your research always starts with a research questions, a problem. If you have defined the problem only, you search to solve the problem. So the question is here, is anemia in pregnancy is associated with low birth weight in newborn or not? I mean, the question speaks about whether anemia is related with the birth weight of the newborn or not. These are research questions. So this question can be concluded in terms of hypothesis. This question can be concluded in terms of what is the hypothesis. So this hypothesis, there are two types. One we called as null. Null means zero. We try to bring zero relationship between these two factors. There are two factors in the research questions. One is anemia, another is birth weight of newborn. So if you write a sentence as hypothesis, there is no difference in the incidence of lower birth weight in the mothers who are anemic and those who are not anemic. I mean, you are saying there is no relationship. You are making it zero relationship. That's why called as null hypothesis. Or you can also give a very research conclusions. It's called as a research hypothesis, and you are predicting that. So this particular hypothesis, nothing but, and the incidence of the low birth weight is higher in women, those are anemic. I mean, the anemic condition of the mother is responsible for the low birth weight of the child or neonates. This is called as a research hypothesis. Next slide, please. See, I hear the different scientists and different people use different synonym or for the hypothesis. Remember, the research hypothesis nothing but scientific hypothesis. Both are same. The same way, the statistical hypothesis nothing but null hypothesis. So more commonly in pharmacy, in our pharmacy, in B Pharm student, M Pharm student, you try to follow research hypothesis. And you have some kind of, based on the literature, you assume the hypothesis, it is expected, then you do your experiment and support your hypothesis. Next slide, please. So these are the example of your hypothesis type. I told you null, there is no. So this null hypothesis also, and once again there is a directional hypothesis. Next is non-directional hypothesis. See, null hypothesis, what we say, nothing but, and there is no relationship between the two factor. I mean, as I told you, that anemia and low birth weight of the child. Directional, nothing but, we are trying to conclude it, directional, more on this side, less on this side. That is called as directional. Non-directional means it's a kind of non-specific statement. There is a difference. There is a difference means we are not saying it's a less or more. That's why called as a null, directional, as well as what is it? Non-directional hypothesis. These direction, non-directional coming in case of your research hypothesis. Next slide, please. Next slide. See, when you write your B Pharm project work and when you write your significance in your studies, people always confuse the objective and rationally. So I'll speak about this objective and rationally. I conclude this speech because as your time is running short. So this significance of the study, nothing but rationally. Many people don't know what to write in rationally. See, the rationally, nothing but why this study is important, to whom the study is important, what are the advantages of the existing. So that is the case where you are going to write your rationally. So when you write your rationally for the work, what you have to highlight? You have to highlight rationally, timeline, relevance of the studies, what are the existing problem, how you are going to implement it, why you are going to improve this, to whom you are going to, how you are going to benefit the studies, what are the advantages, and all the things you want to address in the rationally. Next slide. Next is objectives. So when you write your objectives, and this speaks about nothing but something which you are planning to do or achieve it, and you're not going to talk about importance. The importance of the research is rationally. What you're going to do, what you're going to achieve, that is going to be your objectives. I'll show you some examples of objective in next slide, please. Yes, when you write your research objective, there are two types of writing a research objectives. One is a general objective, another is a specific objective. General objective, we write the objective in general term, but specific, we write very specifically. We break down the general objective as a small sentences, and we write, the general objectives can be divided into 3 or 4 specific objectives. Next slide, please. Next slide. Next slide, please. Yes. This is a sample objective. No, before slide. Before slide. Before. Yes. These sample objectives. No. Yeah, sample objective slide. Yes. Sample objectives. Yes. So you can see the sample objectives. You can see the general objective how they written. To evaluate so and so. There is one paragraph they written. Nobody will understand this. General objective generally they write generally without full stop. Really, you know, when you the exact recommendation what I recommend you student is the objective should be 1.5 sentence. That's all. Don't write even 2 sentences. You know, even for the US people, exactly 1.5 sentence is the hardest sentence to understand. So what I'm saying is objective should be very specific, very simple. You should not use hi-fi language. Your objective should be a very simple language. So here, if you go for the specific objective, you can see I have underlined the word to identify, to determine, to relate. So these are the verb you have to use. The next question is, sir, what is this verb? Where I have to use this verb? Next slide. And these verbs should be taken from Bloom's taxonomy. Next slide. So my final objective of the presentation, nothing but dear teachers and students, I just wanted to introduce the term to you all. It's a Bloom's taxonomy. So wherever you write your verb, wherever you write your research objective, course outcome, anything objectives, don't forget Bloom's taxonomy. I just because the Bloom's taxonomy is a very big terminology, it takes minimum 2 hours to speak to you. And the Bloom's taxonomy is the one that speaks about the learning stage of the what you call this. It's a kind of your the learning, the students learning, and it's a cognitive process of the student learning. The Bloom's taxonomy speaks about the cognitive process of the student learning, and that is represent the verb in case of your objectives. So when you write your objectives, you use only Bloom's taxonomy, and the time permit in future, definitely I'll spend my time to address to teach you to upgrade your teachers about Bloom's taxonomy in future. Next slide, please. Next slide. And apart from that, next slide. PERT chart. What is this PERT chart? It is nothing but program evaluation review techniques. And when you write your project, when you write your methodology, when you write your plan, this should be there. In any project you do, you have to show your PERT chart. The PERT, nothing but program evaluation review technology. It was used in US Army actually. It was used in US Army, how to execute a project. The same thing there in your project book also. You can see in the model slide, I have shown total duration. The duration of the project is 6 months. First 2 months, what are things I'll do? Next 3 months, what are things I'll do? Next 3 months, what I will do. So these are nothing but the kind of PERT chart to be shown in your research objective, research progress, research plan. These are things very, very essential, the key component in the research. And with this slide, because the time is running out, and with this slide, I conclude the fundamental things of, I just want to talk to the students, because as I see many students are there, I not go in depth. And in future, definitely I'll come forward with you and with your, I will be in touch with the principal to enlighten your knowledge still furthermore on Bloom's taxonomy as well as other research design concept. Thank you very much for the given platform. Thank you organizer, thank you principal, and thank you management for the provided opportunity. And if you have any questions, please, I'm happy to answer for the remaining time.
Thank you so much, sir. Thank you so much, sir. Participants, I request you to please mute. Participant, please mute yourself. Thank you so much, sir, for your thorough and deep knowledge on pharmaceutical research, its opportunities and challenges. Thank you so much, sir, for your valuable time. Now, I would request our participants to please ask their doubts and queries in the chat box. You can type your question in the chat box and ask to us, sir.
Okay. So I just wanted to say, because of the timing, because I felt the students were there and just given the very basic fundamental on this world webinar. And definitely I'll be in touch with you, and in future I'll be enlightening much better for the faculty members as well as the students who are interested in future. Because many cases, because what I given here, it's many students know, they are not aware of that, how to identify a research problem, and what is the need, what are the various areas to be focused, and what is the rationale, what is the objective, what is PERT chart. These are the very basic fundamental things lacking in the BPharm student right now when you go for the project evaluation. So what are the components I given, like objectives, Bloom's taxonomy, and the PERT chart, and defining objectives, and writing a rationale exactly. So these are the basic things required to be learned in a BPharm level. The student should develop the knowledge in that aspect.
Yes, sir. Sir, not only the students, but we faculty who are into research, we are also benefited through this presentation. So I wholeheartedly thank you, sir.
Okay. Yeah, definitely. For your faculty, definitely we'll have a separate sessions, because there's a student community out there. I just focus on the students only, and for your faculty, I'll be in touch with you. I'll be going little more depth to enlighten you on these aspects once again.
Yes, sir. Thank you so much, sir. And I regret for the inconvenience caused, sir.
Yes.
I apologize for the technical issues, and I regret for that, sir.
No. I'm happy. I'm happy with your technical support. I'm happy with your organizing and all those things, and everything is supportive. I'm happy overall. And there is one question they asked. I think there is one question.
Yes, sir. So let me see the question. Oh. Okay, sir. There's no such question yet till now in the chat box. We haven't found such.
Yeah. No. Privately they asked me. Privately they asked me some questions, and one student asked, "What is the sector we should focus?" They asked. So overall, as I told you that you students and whatever the future studies, your focus should be towards a research orientation. Because as I told you that by 2030, I'll tell you, I just use a word, drug resistance. So that drug resistance is not only antimicrobial, we have antimicrobial resistance, antiviral resistance. Anti-cancer resistant, and whatever the drugs available for chemotherapeutics or pharmacotherapeutics, nothing will work in future. We have to go for individualized and personalized medicine also in future. Personalized, the medicine which are given to me, it may not be suitable to you. So we are in the need to go towards the personalized medicine, and you have to focus on chemotherapeutics. My answer is nothing but you focus on the chemotherapeutics like anti-cancer, anti-TB, and antibacterial. Because 10 years before, I'll tell you my experience. 10 years back, I'll share with you my experience to you students. 10 years back, I attended an Indian Pharmaceutical Congress. I presented a paper, antibacterial agent. So the evaluator told, why still you are doing antibacterial agent? Already we have antibiotics. Why you want to do research? But right now today, WHO announced that in future there is an urgent need for new antibiotic because the new antibiotic, all the antibiotics are become resistant. So the things will change. Don't whatever time we felt antibacterial discovery is the oldest. Now it is a very recent.
मुझे तुम पे भरोसा नहीं है.
बॉस को
Next.
Yes.
যদি একটা থেকে কম বেশি বেড়ে না
Participant,
না বেড়ে একটা থেকে কম বেড়ে
participant, please
একটা
mute
বেড়ে না
yourself.
Yeah, I say Assam now, you know, I'm telling you, you focus on anti-cancer, antibacterial, antiviral, and as well as you can go for neurodegeneration, like, you know, neurodegeneration means Alzheimer's.
Thank you, sir. Now, I would request
Okay.
Ms. Rupsika Malakar, Assistant Professor, NEF College of Pharmaceutical Education of College of Pharmacy, Guwahati, to please deliver the vote of thanks to P. Ramalingam, sir.
Okay, thank you.
Rupsika, ma'am.
Okay, thank you, ma'am. Am I audible, ma'am?
Yes, ma'am, you are audible.
Okay.
Yes, yes.
So, myself, Rupsika Malakar, Assistant Professor from NEF College of Guwahati, and I wish all of you a very happy World Pharmacists Day 2020. On behalf of NEF College of Pharmacy, Guwahati, and NEF College, Nagaon, I take this opportunity to propose a vote of thanks to one of our honorable delegate, Dr. P. Ramalingam, sir. So, sir, your talk on pharmaceutical research and opportunities and challenges in drug discovery was really very informative. I hope it would be helpful for most of our academicians and students as well. So we are very grateful for the time and effort you took to share your thoughts and experiences with us. It's been a great pleasure, sir. Thank you. Over to you, Unti, ma'am.
Yes, ma'am. Thank you, ma'am.
Thank you. Actually, to be frank, I have not focused detail on the challenges opportunity. I just given the fundamental to the students, and I'll be joining with you, a faculty member, very near future to talk about detail about all the challenges and opportunity in a correct location, because the time is very short. So I just completed based on your lunchtime. Many of you waiting for hungry for that. So it's thank you very much. Thank you, organizers, principal, and for entire team. Thank you. Have your nice lunch and catch you sometime and meet you soon once the COVID pandemic is get right.
Thank you so much, sir. It was our privilege that you are with us. Thank you so much. Now, moving on to our next session, here I would like to say about a wonderful quote by Thomas Carlyle, which says, "He who has health has hope, and who has hope has everything." Now, let us proceed and gear up ourselves to listen from our next honorable resource person, Dr. Amitava Ghosh, CEO and founder, Unicorn Academy, Australia. But before his lecture session, I would request Saurajyoti Dekar, sir, Assistant Professor, NEF College of Pharmacy, Guwahati, to please introduce sir through his introductory speech. Dekar, sir.
Good afternoon, everyone. Am I audible and visible?
Yes, sir, you're audible.
So, good afternoon, everyone. So, first of all, thank you to all dignitaries, all resource persons who have enlightened our day from morning onwards. And now we have come to meet our third most generous person for today's day, resource person, who is actually Professor Dr. Amitava Ghosh. So let me introduce to all of our participants regarding Dr. Amitava Ghosh. So Dr. Amitava Ghosh, sir, he did his B.Pharm and M.Pharm from Jadavpur University, Kolkata, and earned his PhD from University of North Bengal. And later, sir completed his MBA from Sikkim Manipal University, India. Dr. Amitava Ghosh sir is having a total experience of 17 years in pharmaceutical teaching and research in major portfolios such as principal and as HOD, head of department for pharmaceutics in different pharmacy colleges across India. He is having 87 research publications, 5 books, and 2 international chapters. Currently an Australian citizen, Dr. Ghosh is an entrepreneur and an educator in hydration science and a professional in molecular hydrogen therapy. He is also a STEM, science, technology, engineering, maths professional for CSIRO Australia and a student mentor for University of Adelaide. He is on the advisory board of American Biographical Institute and also in editorial advisory board of International Journal of Pharmaceutical Sciences and Biotechnology, International Journal of Drug Formulation and Research, as well as Asian Journal of Research in Pharmaceutics and American Journal of Pharmaceutical Technology. He was the founder editor of the Journal of Fundamental Pharmaceutical Research. He is a member and life member of many scientific organizations. He has served as vice president of Association of Pharmaceutical Teachers Association, APTI, for Sikkim branch in India. His research interest includes therapeutic benefits of molecular hydrogen, structured water, pharmaceutical formulation development, and their statistical optimization. So these are some of the few small words about Dr. Professor Amitava Ghosh. So with this, I would like to welcome our third resource person, Sir Amitava Ghosh. Please join us and share your knowledge as well as experience for the day on this graceful day of World Pharmacists Day. Over to you, sir.
Thank you, Saurav. Thank you, Saurav Deka, for that lovely introduction.
Thank you.
It's been a great honor. It's a great opportunity to be with you today, being on a far distance from India, but it gives me a lot of pleasure when I see students and faculties in pharmacy organizing such webinars and seminars. In fact, the COVID thing, since it has come, has actually done a lot good thing. Like they have broken the barriers, geographical barriers, and helped people sitting in their place, delivering lectures and seminars and sharing their ideas with many people, which is very good. Firstly, I want to congratulate everybody there. I think most of them are linked with pharmacy. So on the occasion of International Pharmacy Day, which is 25th of September, I congratulate all the budding pharmacists and the would-be pharmacists and already been a pharmacist there. It's a great honorable day for all of us who are with the profession of pharmacy. Before I start my topic, I know mine is the third one, so you might all be a bit hungry or a bit tired or bored. I know it's constant listening to webinars, especially sitting in front of computer. It's stressful. But I first would like to convey my thanks and my to Dr. Zakir Hussain, who's the director of NEF Group of Institution. Mrs. Farhana Ahmed, Assistant Director of NEF Group of Institution. Dr. Raja Chakraborty, who's the Principal of NEF College of Pharmacy, and Dr. Debo Pratim Das Gupta. Incidentally, he was one of my students. It's a great privilege to get invite from Debo Pratim. He's a principal now, and it gives me immense pleasure to see my ex-students now. They are at the top part. Most of my students are doing very, very good. Most of them are vice presidents, presidents of some pharmaceutical companies, principals and professors of many other colleges. So yeah, it's something amazing. Only a teacher can understand that. Who I am, I was a teacher and I'm always a teacher. It came with my gut, and so I never thought of doing anything else than teaching. just after completing my master's from Jadavpur University, Calcutta. But now, after shifting to Australia, I have seen the world in a different perspectives and came with a new concept of technology, which is a pretty original in its nature, which is molecular hydrogen. And today I thought, like, on this day, since pharmacists are the backbone of healthcare and well-being of the world, along with doctors, physicians, surgeons, playing a very important role in the healthcare team. I thought, instead of going through the basic theories or topics of pharmacy, let's share something which is pretty new, pretty in, and pretty original. So let me share my screen. Uh, there is a chat box, so I request everybody to keep yourself muted, because if you keep yourself on, then a lot of noise comes in and becomes more disturbing. So kindly keep yourself muted. You can keep your videos on. I would love to see your faces, but then sound can be muted. If you have any question, just raise uh, that in your chat box, and maybe at the end of the session I would be answering them definitely. Uh, is my slide visible to all of you?
Yes, sir, it is visible.
All right, fantastic. Thank you. So yeah, molecular hydrogen. Now we know about this hydrogen. Everybody, we are in pharmacy, so uh, we know the basics of chemistry, and we have seen this element called hydrogen, H, being the first and the foremost and the first element in the periodic table. Being smallest and most abundant element, we normally don't give much heed to it. And if you remember the activity series of metals, hydrogen comes at the very low position. So hydrogen can be replaced by many other elements, especially metals. So hydrogen is considered to be one of the weak in terms of activity. So hydrogen is kind of a most neglected one. But how many of us know that the smallest element in the nature is the most abundant element of the universe? The most abundant element of the universe. So if we go out of the earth, just get into space, cross the atmosphere, go up, 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 and once we are into space, the element which we would come across constantly bombarding us is the hydrogen gas. As I said, located in the periodic table number 1, the first element in the periodic table. It's the most important element in the sense that it decides the acid-base chemistry. The acidity or the basicity, we know about the pH, we know the negative logarithm of hydrogen ion concentration, which we call as a pH, and it's measured through a scale of 0 to 14, is nothing but the measure of hydrogen. And let's go into before going, I'm not going in much detail into the isotopic things, the protium, deuterium, tritium, which are the 3 general isotopes of hydrogen, where you have in the protium you have got no neutron, and in deuterium you've got 1, and the tritium you have got 2. They all have atomic number 1, but they have mass numbers of 2 and 3. But then the facts are that this is the lightest element, the most abundant of all, doesn't have any color, no odor, means no smell. It's absolutely non-toxic, and non-carcinogenic. Now, this word is very important for us, especially in today's scenario. We are cancer, COVID, COVID would go off. Once a vaccine would be there in the market, COVID would slowly be under control. But cancer, big question mark. Uh, it's actually increasing exponentially every year. Now we need to find which is non-carcinogenic. So we are in a entire pharmaceutical research is on mostly focused on anything which is non-carcinogenic. So this is one of the non-carcinogenic gas I'm talking about. And this is a gas which is not found by itself on Earth. You won't be able to find hydrogen in the molecular form. That's why the title says it's a molecular hydrogen, H2. You won't get hydrogen in its molecular form, just like you get oxygen in a molecular form or nitrogen in molecular form in the atmosphere. You won't be able to see hydrogen in the molecular form because it mostly uh, is found in the combined state in the form either in the form of water or in the form of different organic compounds in the form of hydrocarbons like methane and so forth. Uh, I'll talk about this later. I'll come back, but then let's slightly go through a story how hydrogen got evolved, the evolution of hydrogen. It's a very long story, but I'll cut it short. I know there's a time limit. Big Bang, that's the theory which still holds pretty true, though there are different school of thoughts how Earth and the universe came into existence. Big Bang is one of them. Uh, it was a tremendous, massive bang. It was a blast which took around 10 to the power of -6 second to 1 second of a blast, and the universe expanded. The moment the blast occurred, it started cooling off quickly. And there was a massive change in temperature all around. And the ambient temperature in the universe, uh, you won't imagine the figure. It's a 1 trillion degree. 1 trillion degree. But just after the bang occurred, the universe started expanding. And when it expands, when anything expands, the temperature drops. So from 1 trillion degree, just after that blast, the temperature started cooling down and it came around 80, it expanded around 80 billion and the temperature started falling. As a result, when the blast occurred, there were a lot of small particles all around the universe, which we call as quarks. These quarks started colliding with each other. And out of this collision, the outcome was formation of two subatomic particles, which we know as protons and neutrons. These protons are the first atomic nuclei. Now, we know hydrogen is nothing but a proton because hydrogen has got one proton. The protium isotope of hydrogen has got just one proton. So we can say hydrogen are as old as universe. So the first element which took birth after Big Bang, after the expansion of the universe, was hydrogen. So we are talking about the father of all the elements, hydrogen. Now then, with further expansion and further time, which in the world of science they call primordial nucleosynthesis, which is basically nothing but nuclear fusion. The neutrons and the protons which are formed, they went on colliding with each other. And it resulted in another new element called helium. So you won't believe that all the elements what you see on the periodic table today are basically generated from hydrogen. So hydrogen with another hydrogen with fusion created helium. Helium with another hydrogen created lithium. With another hydrogen created beryllium, and so on and so forth. Now, those other elements are rarely found in the universe. What you would get in the universe is mostly hydrogen and helium. Helium has got a lot of connection with this thing, which personally I consider is as God. Whatever religion you follow, you won't see who is God, but you can see this one every day shining in the sky. And when you see it, you get energized because this is a ball of fire where constantly nuclear fusion is occurring, creating massive energy. I'm not going into the physics of the energy and stuff. I'm just trying to give you a story of how hydrogen can lead to therapeutics. Now, this ball of fire we know as sun. It's a fusion reactor, and it's still reacting, and it would be reacting for another billion years. And the day the reaction stops, the sun would die and would get sucked into the black hole, and that would be the end of our solar system. Uh, this sun is related with heat, which starts with He. Sun is related with heaven. We think, oh, the sun is in the sky, there the heaven lies. Again, starts with He. And sun has another name of sun in the Greek, through Greek word, sun is also called Helios, Helios, and from where the name of the gas helium came into existence, from Helios. So another name of sun is Helios. So inside the sun, the reaction is occurring with two hydrogen, and we are getting helium gas. And the energy which is generated there is massively, massively high. If you look at the space, you see 74% of the space composed of hydrogen and 24% of helium. Rest are the gases. So 98% of the gas is composed of hydrogen and helium. Whereas you come down to Earth, which is a byproduct of the sun, the atmosphere is absolutely different. Nitrogen 78% and oxygen 21%, which makes 99% of the atmospheric composition, leaving just 1%. So actually hydrogen in the molecular form is around 0.000002%. But when the Earth was born, it was just a ball of fire. It just came out of the sun. All the planets came out of sun, and there was a shoot of big ball of fire which came out, just like when we fry pakoda, uh, you know, and after frying, you bring it out. The top part, the crust of it gets solidified, but the inner part still remains very hot. So when we eat, you feel that burning sensation or the hotness of it. Similarly, the earth is still very hot inside, resembling what we see in sun, but the outer crust has solidified, and that crust composes of a lot of other elements. Now, at the beginning, when the earth was born, the first atmosphere was only composed of hydrogen because it came from sun, hydrogen and helium. But then hydrogen cannot exist on earth's atmosphere for long. Slowly, hydrogen started combining with other gases, other elements, and forming other compounds. And now, after millions of years, there's no more hydrogen existing in the Earth's atmosphere. It's mostly either water or ammonia or methane or many other hydrocarbons. So if you look at this, this is universe, which is mostly composed of hydrogen and helium. Whereas on Earth or Earth's crust, the top part on which we are living, it's mostly oxygen. The abundant element on Earth is oxygen, followed by silicon as a solid element, then aluminium, iron, and many other metals. But if you look at the connection between universe, Earth, and life, our life is dependent on oxygen mostly, followed by carbon, hydrogen, nitrogen, and calcium, phosphorus, magnesium, zinc, and so on. So oxygen is there on Earth and in life, but hydrogen is there in space. So what's the relationship between this? How this hydrogen can be of help to us? does it have any good for us? Does it have any benefits for us? Researches were done, and it was found that yes, hydrogen has got multiple uses. We know that hydrogen is used to refine crude oil, like whatever petroleum we get, we refine them with the hydrogen, and we get the refined oil, what is used as a petroleum product, so petrol, diesel, and so on. Hydrogen creates clean electricity, so hydrogen can be used as a nuclear reactor element and can create clean electricity, and it's one of the most renewable source of electricity. Hydrogen is used to make fertilizers. Hydrogen is used to convert oil to saturated fat, like oil to dalda. Hydrogen is used in electronic industry uh, because of it can actually resist extreme heat and extreme cold condition, because it's a gas of space. It's not a gas on Earth. And hydrogen binds all the molecules together in chemicals and pharmaceuticals. So it's one of the most common reducing agent in the world of chemistry and pharmaceutical science. Where it is applied in today's physical and material world, hydrogen is used as storage in pressure vessels. Hydrogen is used as an electricity system. So fuel cells, most of the fuel cells, I think by next 10 years, you would be seeing hydrogen cars in the market. So like Elon Musk is working on that. So no more fossil fuel would be there. It would be most of the hydrogen cells. So we are hoping that would come, and that would actually reduce the carbon content of the atmosphere. Hopefully it would clean up our earth and reduce the global warming. Hydrogen is also used in refining industry. I told that. It has got various other applications in shipping, aviations, used in transports. Uh, the reason of being used so much in the mechanical industry sector is, again, because it burns clean. When hydrogen burns, it forms water, and that's the biggest advantage of hydrogen. No carbon dioxide, no sulfur dioxide, nothing would happen when hydrogen undergoes combustion. It's colorless, it's odorless, does not toxify the atmosphere, produce no flames when it's burned, and the high combustion temperature. It has got a very high combustion temperature, so heat content of hydrogen is very high. Uh, and again, it's very lightest weight, so it can be transported easily. Uh, and it has got an extremely low boiling temperature, so it would never ever solidify. It would always remain as a gas. Now, those are all good side of it. What is this? The bad side of it. The atom bomb, or the Tsar bombs, the hydrogen bombs. Hydrogen is so powerful in nature that it's like, we are into pharmaceutical industry. So all pharmaceutical medicines we call it a drug. But what is drug? Basically, we say drug and narcotic. What's the hairline difference between them is when the drug gets overdosed, it becomes a narcotic or toxic. Similarly, hydrogen can be used in a malified intention using hydrogen bombs, but that gives us an indication that the power of hydrogen is tremendous. This is a very popular quote. I'll follow this man through his YouTube channel. Michio Kaku is a world-renowned physicist. He says, hydrogen bomb for me was a puny compared to the Big Bang. So Big Bang was massive compared to a hydrogen bomb. Hydrogen bomb is nothing compared to the Big Bang. You would be soon, these are already in the market, so you would be seeing soon in India, like hydrogen buses would be all around with zero emission, no gases coming out. Rocket science, they use hydrogen for a long time. So plenty of uses all around the world for hydrogen. This guy, I purposefully kept him on this slide. He's from Vellore, Devendran. I think he's in year 12 now. I think he's already passed. He's into college. So he used hydrogen in a cell. He made a hydrogen cell and run his small scooty. And his project was really applauded by VIT University. And now VIT University has given him scholarship and he's working on hydrogen cell. So it has got tremendous potential. Having said that, if we look back to the timeline of hydrogen, 1520, the gas was first explored in 1520, uh, followed by Lavoisier, who's a modern father of chemistry. We know him for finding oxygen. He only named oxygen as an oxygen. He coined the French word hydrogen too. Hydrogen means the water generator. Hydro means water, gen means generator. So this is the gas which helped to form water, and that's why we are living on this earth. Any other planet you go, you don't find hydrogen, and that's the reason they don't have life there. There's no water. In 1783, hydrogen balloons were made as a carrier. So people started flying on balloon, another big use of hydrogen. And then around 1843, we started seeing some publications concerning the different forms of hydrogen. Around late 19th century, hydrogen was linked with some medicinal value, and people find that hydrogen has got some medicine. But in 1937, Hindenburg came out with the explosion power of hydrogen, and then there was a big lull period. Nothing, a lot of research went on in many other things, not much on hydrogen in context to medicinal world till 2007. Till 2007, Oshawa et al. Oshawa is from Japan. His team worked on hydrogen and found hydrogen as a therapeutic antioxidant, as the hydrogen was found to selectively reduce the cytotoxic. Cyto means cell, toxic means, so anything which toxify the cell, uh, those are called cytotoxic free oxygen radicals. Hydrogen was found to selectively pick those free radicals and reduce them, so acting as a very strong antioxidant. And the paper came out in Nature Medicine. Nature Medicine is considered to be one of the topmost journal in the world, with the impact factor of 32 plus. Thereafter, from 2007 to 2020, it's been more than 2,000 papers now, all working on the effect of hydrogen on different uh, clinical conditions, and all have received significant amount of uh, results, which are really promising. And it's going to be a game changer very soon. Now, before I go into that part, let me show you some slides. Unfortunately, we are on a webinar and I can't ask you to unmute yourself. A lot of noise would be there, but I think some of you might identify this picture. This is from Mecca. Um, Whoever goes for Hajj to Mecca, they definitely bring some water from there, and they consider it to be holy water. And there's another name for it. It's called Zamzam water, Abe Zamzam. They're called miracle water because these water, when you drink them, it has got a lot of healing power. You get healed of. That's why they are also called holy water or miracle water. Now, the other picture which you see beside is, I think you have already identified, it's Gangotri or Gomukh, from where the river Ganga flows. It's called, and the Ganga Jal itself. Then there are some holy waters all around the world. That's from Mexico, La Corte. That's in Germany. It's in Northern New. It's in France, Lourdes. They're world famous places. People go there, flock there. just to get some water and to get healed from many, many ailments or illness. Uh, excuse me, if somebody can get rid of these lines, I'm getting somebody's writing on it.
Yeah, yes, sir. Uh,
Yeah, I can see somebody's writing on it. Yeah.
yes, I request candidates, participant, please don't scratch in your screen. It is creating problem. Participants, please don't scratch on your mobile screens.
So this is Professor Oshawa and the paper which I was talking about, which came out in Nature Medicine, which is a landmark paper and changed the entire concept of therapeutics. And in till 2020, I think this is still 2017 figure. You can see most of the key diseases: cancer, tissue dysfunction, sensory systems, reproductive system, all the physiological system you talk about, digestive, metabolic, respiratory, urinary, cardiovascular, especially central nervous system, hydrogen has been found. So there are more than 80 to 100 papers which show significant effect of hydrogen on CNS. Around 70 plus papers on cardiovasculars, around 20-25 papers on cancer. Now it's pretty less. Now it's 2020. At this 2020, we have got more than 60 papers, and all are in Nature's and similar kind of journals, which says hydrogen has got so much positive effect on therapeutics, on these diseases, on these systems. Basically, it acts on all the systems. It acts on all the organs of our body. It acts on brain. So it has been found to have positive effect on Parkinson's, Alzheimer's, ischemic brain, on eyes, on lung, on our auditory system, or our kidney system. Like I know people whom a doctor has decided like he has to change his kidney, transplant kidney, went for transplantation, but came back after having hydrogen therapy. He didn't change his kidney, his creatinine came down. So there are hundreds, thousands of testimonials like this. Diabetics, all metabolic diseases, uh, they have been found to get cured out of hydrogen therapy. Uh, so what is molecular hydrogen all about? And why it is showing good effect in therapeutics? The reason being, as it is the smallest element and the smallest molecule, it easily diffuses into the subcellular compartments. Being smallest, it does not need any permission from the cell membrane. It can easily pass through the cell membrane, and once it goes inside the cell, inside the cytoplasm, it scavenges those free radicals which are cytotoxic, and thereby protects the DNA and the RNA and other proteins which are inside the cell, and thereby reduces the oxidative stress of the cell. It is such a small molecule that it can cross your blood-brain barrier. The only gas which can cross blood-brain barrier, BBB, is a hydrogen gas, molecular hydrogen. And that's the reason most of the neurodegenerative diseases have been found to have profound effect with molecular hydrogen therapy. It also triggers the upregulation of additional antioxidant enzymes. So after it triggers once molecular hydrogen gets into your body, it triggers other antioxidant enzyme to come out, like glutathione, like dismutase, and so on. So additionally they protect us from any sort of oxidative stress. And oxidative stress is the key underlying cause of all the disease around the world. What are free radicals and what are antioxidant? I'll just touch it because time shortage is there. I can speak hours and hours on this, but then free radicals are molecules, or radicals rather, but they're not complete molecules. They are deficient in electrons. So these are electron deficient chemical moiety which which searches for electrons all around our body. And whenever they get an electron, they jump on it, eat on it, try to get satisfied. And as a result, from where they are picking the electron, that thing loses the electron. And you know, loss of electron is oxidation. So the other thing gets oxidized. So cells are, what are cells? Cells are nothing but battery. All our body cells are battery, just like the cell which you use in your watch or in your any torch or anywhere. They are battery. We call them cell. Even our human cells are called cells because they are all battery. They have got electron volts. Now, when these battery loses charge to this free radical, this battery gets discharged. Now, to recharge this battery, we need some antioxidant who are rich in electron. So we need electron rich food or electron rich material to go inside our body so that our human cells can get recharged, gaining electrons from it. What are the free radicals which are dangerous for our body? Not all free radicals are bad. There are some good free radicals too. I'm not going into those debate now. But these are the common free radicals which actually affects us. Hypochlorite, superoxides, peroxides, nitric oxides, hydrogen peroxides. Now you can see bromine or fluorine, fluoride in fact they are. And the hydroxyl radical. This is the dangerous one. These are commonly called reactive oxygen species or ROS in the world of chemistry and biochemistry. What happens like it's a four-step process where oxygen gains electron and becomes superoxide, and superoxide gets converted to hydrogen peroxide by gaining another electron, and the hydrogen peroxide then gains another electron, produces one hydroxide ion and a hydroxyl radical. There's a big difference between hydroxide, like calcium hydroxide, magnesium hydroxide, that's an ion. Whereas hydroxyl is a radical which has got deficient in electron. This hydroxyl radical is the dangerous one. And this hydroxyl radical gains the electron and becomes hydroxide. As a result, the person who donates that electron gets oxidized, and that leads to aging. That's why we grow old. That's why our hairs becomes gray, our skin starts wrinkling, everything, like we start growing old. If you actually go back in ancient times, humans used to live for more than 150 to 180 years. But now even 80 to 90 years is our average lifespan is 85 years. And Japan actually has got a highest lifespan around the world. It's 87 years. From where these free radicals comes in? There are three main sources. The key source is environmental, like smoking, like the pollutions in the air, car exhausts, like indoor cooking fires, like barbecues and all, or within our cells. Like our cells every cell have got this powerhouse which we call as a mitochondria. Inside the mitochondria, respiration occurs, we know that. Now, if that respiration occurs and produce these free radicals come out and slowly continue oxidation in search of electron, and that's called lipid peroxidation, and that leads to tissue damage. So the lipid layer, the phospholipid layer of the cell membrane undergoes oxidation, which we call lipid peroxidation, and thereby the tissue or the group of cells starts dying or starts getting damaged. Now, if that damage level reaches up to the DNA, then the cell starts getting mutated. And as a result of that mutation, what we are getting is cancer. We are getting poisonous toxic cells. So one cell with a cancerous carcinogenic DNA can through mitosis produce multiple carcinogenic cells, and they grow abnormally fast, and that leads to cancer. So we need to find out, as a pharmacist, we need to find out something which can block the lipid peroxidation, or also called oxidative stress. Because these oxidative stress is, as I said, it's an underlying cause of all the disease. All the disease. No medicine can actually treat this oxidative stress. They just can temporarily block the symptoms. But generally, this oxidative stress is a kind of an underlying cause of all disease. All bone pains, joint pains, arthritis, rheumatism, lung problem like asthma, like brain problem, neurodegenerative problem like Alzheimer's, Parkinson's, and all, or brain stroke, or organ failures like aging, diabetes, infections, or any sort of inflammation are due to oxidative stress. Uh, let's not talk about this. Let's jump into it. So what happens is a normal cell undergoes lipid peroxidation by the free radicals, and the cell starts wrinkling, and then cell is under a lot of oxidative stress, and slowly it dies, and it might convert after DNA gets mutated, it might get into a cancerous form. Now, what are antioxidants? The antioxidants are those molecules which fight against these free radicals, try to scavenge them and provide them electrons. We know vitamin C, vitamin E, they are popular as antioxidants. We get them from fruits, from vegetables, from green stuffs all around. Carotenoids is another popular antioxidant, like carrots, fruits, eggs. Then polyphenols like resveratrols and all, we find them a lot in tea, coffee. So we say that drinking green tea is good for us. That's an antioxidant. Chocolates like dark chocolates, olive oils, fruits, red wines, they're very good antioxidant. But the problem with these natural antioxidant is when they donate the electron to the free radical and convert the free radical into a molecule, they itself becomes electron deficient moiety because they have lost their electrons. Now, who would control them? That is a big problem. And there lies the advantage of hydrogen being a natural antioxidant. When hydrogen, when hydrogen donates its electron, what it does, it actually converts a hydroxyl and converts hydroxyl ions to hydroxide, and hydroxide and hydrogen ion combine to form water. And water is what our body is made up of. 70 to 72% of our body is composed of water. And you would be amazed to know our Earth's composition is pretty similar. 2/3 of Earth is water, as like our body. 2/3 of our body is water. Rest is the other mass, the muscles and the skeletal. Even the Earth is land, rest is land, and 2/3 of it's water. So there's a very common, very definite link between the Earth's composition and human body composition. And that link, if we can connect that link, there lies the importance of molecular hydrogen. The goodness of molecular hydrogen is it do not form any toxic compound after antioxidizing the free radicals. And number two, having the lowest molecular weight of 2 compared to 176 of vitamin C and others, molecular hydrogen can diffuse easily to any level and can find and selectively convert those free radicals into a molecule. I think the time is going short. Okay. So the key thing about why molecular hydrogen acts as a superior antioxidant than any other antioxidant in the world is its selectivity. It has got an inherent intelligence in it. It sees who is that which is causing us problem and selectively scavenge it and reduce them. It is zero toxicity and it is homeostatic. On this, there are, again, as I said, more than 2,000 great papers all around the world. You can just go to Google Scholar and write molecular hydrogen and its therapy, and you'll find heaps of paper coming down. Uh, I'll show you some important picture rather than going into the much theory. You would be amazed to know that when we wake up, and if you take your blood sample and put it under microscope, your blood sample would look like this. Your blood cells, the red blood cells, they would stick together. And that's why when you wake up, you have pain in your body. You're not that free. When you're young, it's fine. But when you grow old, your blood starts sticking. And that reduces the surface area, effective surface area of the red blood cells. Hence, their oxygen intake capacity goes down. And that's why your body energy level is low. The moment you have hydrogen in your blood, these cells, they separate out. Their motility increases drastically within 15 minutes of infusing it with hydrogen. And you get to see your blood cells are moving very fast. So like when you move very fast, they start uptaking a lot of oxygen from the lungs, and your body gets to produce more and more energy, and you overall find a lot of energy. All your cells, all your batteries gets recharged quickly. This is called rouleau formation of cells, and this is a massive reason behind all inflammations in our body. Now, how to transfer that hydrogen into the blood? Because blood is the carrier, and blood can only take hydrogen to the cells. To take hydrogen to the cells, we have to pass it through the blood. What are the different modes of transferring? What are the modes of administration of hydrogen? Now, you can inhale hydrogen as a gas. You can put a mask. About everybody now knows about mask a lot with this COVID thing. So you put a hydrogen mask. There are some some parlors, hydrogen parlors in China and Japan. Japan is a key country which started working on it in 60s and 70s, and they actually start working on these holy waters like Zamzam waters and Gangajal and all the holy waters around the world. Russian and Japanese scientists, they went there and pick up the water from the from these streams, and found that these waters are why they're healing, why they're miraculous is they have got free molecular hydrogen concentration. They have a high concentration of free molecular hydrogen in them. And that's the reason if you go to any hilly place, you won't fall sick quickly. You might get a bit of a hill diarrhea, that's due to the bacteria and the non-hygienic condition, but otherwise you won't be suffering from pain. You won't be suffering from any other heart disease kind of thing. Uh, just and that's the reason people go to hilly place just for holidaying, because that gives them a recharging because of the nothing but the water there. The hilly waters have got free flow of hydrogen in it, because the water, when it passes through the rocks, gets electrolyzed and hydrogen is formed naturally in them. Japanese scientists found that much ahead in 70s, and they created hydrogen inhalation therapy, hydrogen water saturated in saline, hydrogen and palladium nanocrystals, and they also formulated hydrogen dissolved in water, and they started drinking hydrogen rich water, which they call it as Kangen water. Now, these are the different methods of administration. Hydrogen rich saline injection, but for that you can't take it daily. If you want to stay free from cancer, free from any other disease, free from obesity, and try to stay young for long, you need this hydrogen daily. Either you can take hydrogen tablets, uh, and you add the tablet to the normal water what you drink, and daily drink a glass or two. You get good effect of hydrogen slowly. Or you can go to these hydrogen parlors where you can sit and have some naps, just like you smoke cigarettes. You can smoke hydrogen. Or you who is writing on this, it's creating you can take a hydrogen rich bath, or you stay in a hilly place, or you have a hydrogen generating water machines. Now, this is the water machine. This is the water which comes out of water machine. Uh, this is my own kitchen where I drink hydrogen water daily. So you see, once the previous machine, which has got 8 electrolytic plates, which electrolyzes the general normal water which goes in, gets electrolyzed. One on one slide, it's a hydrogen, another on another electrode, you get oxygen. So there are 2 pipes. The one which comes out as a drinking water is a hydrogen-rich water. The other which comes out with full of oxygen is a highly acidic water, which can be used as a sanitizer, can be used as a beauty water for cosmetic use, and many other. Now, this is the water. You can see that cloudiness in it. It's nothing but hydrogen, molecular hydrogen. The good thing is it's full of antioxidant, and the bad thing is you can't store it for long because hydrogen cannot be stored. If you keep it open, after a few minutes, you will see the molecular hydrogen would actually mix in the atmosphere, and then water would look like normal water. So this water has to be, you need to drink it fresh, straight away. Now, I don't know how many of you are aware of this term called oxidation reduction potential. This is electrolysis which I was talking about. Now, oxidation reduction potential is very, very important parameter in understanding the power of oxidation and reduction of many food, what we eat or drink. We think like we know now everybody says now that alkaline food is good. Our body needs to be alkaline. Our blood is 7.4 pH, so it's slightly alkaline. So we need to be alkaline, alkaline, alkaline. So why don't we drink some sodium hydroxide solution, which is strongly alkaline? Is it good for our body? No. No. It's not the pH or the alkalinity of the food which is good for our body. It is the oxidative reductive potential, which is a measure of electricity, which is measured in millivolt, which is important for our body. Anything which is positive in oxidative reductive potential, positive potential would oxidize our body, which is not good. Oxidize means burn our body. Anything which is negative in ORP would reduce our body. So think of, we know lemon water is very good, lime water, or apple cider vinegar is very good for our body, right? Or even green tea is very good. Green tea is very popular in Asian countries. Any citrus fruits, very good for our body. Are they alkaline? Lemon water or lime water, green tea, orange, lemon, apple cider vinegar, are they alkaline? No way. They are highly acidic. Their pH is around 3, 2.5. Even being that much acidic, they're good for our body. Why? Because of their negative ORP, oxidation reduction potential. That means these things, when they go inside our body, has the power to reduce our body and bring back the youth. When we are born as a baby, our body is highly alkaline. And slowly as we grow, we undergo a process called aging, and that happens due to oxidation. And they and that leads to old age. So if we can keep our body in a reduced state, then we can keep our youth for a prolonged period of time. The machine or the the hydrogen infusion water machine can generate an ORP less than 400 to negative 1000. Whereas the colas and soft drinks or the Gatorades or the energy drinks, what you see the sports people drink, they use their ORP is highly in the positive side, so they basically oxidize you rather than giving you. They might give you immediate energy, but in fact underlying they are oxidizing you. The normal water, purified water, bottled water, all are oxidizing, so they are no good for our body. Our body needs something which is negative, so focus on change your nutrition or ask your friends, relatives to eat or drink such a thing which has got negative ORP and not the positive one. If you want to live long, be free from cancer, be free from any sort of disease, always look for something which is negative ORP. Uh, this machine was actually designed in 1970 by the Sony research company who makes Sony TV, and then sold it to another company. And for that, from then onwards, from 74 to 2004, in Japan and Korea, it's a only medicated water device and the medicated water technology. They consider it to be the only medicated water which doctor can prescribe through RX. Uh, one glass of pure hydrogen water, also called ionized water, has got that antioxidant power which is equivalent to 756 bananas. Just think of the power of these hydrogen water. If you eat 756 banana, the amount of antioxidant which you would be ingesting would be equivalent to 1.5 liters of hydrogen water, or equivalent to 516 apples or 38 carrots and so on. And these are all researched value, not just, it's Japan's Shimata University research. So it's a data based on 550 parts per billion of hydrogen content. This is the man who said, who got Nobel Prize in 2003, Dr. Peter Gregory. He said that there is a certain channel in every cell we called as aquaporins, or water channels. And the hydrogen water is basically a nano-sized water. So we say it's a structured water. And the world started working on structured water. Right now, the research is more on structured water. Anybody who wants to do PhD can start working on structured water. Structured water is an hexagonal shaped water, which only is formed when it gets electrolyzed, either naturally on the rocks or in a device. So those electrolyzed waters are ionized, where all the essential minerals are found in the nano form, so they get absorbed very easily. Our body gets super hydrated, and the water gets easily flushed into the cells, bringing out or scavenging all the free radicals from the cells, bringing back all the energy and recharge our cells. So due to that hydration, a lot of diseases which are caused by dehydration can be cured by hydrogen. That's asthma, allergy, arthritis, and so on. Obesity is one of them. Dehydration is a main cause of migraine or headaches. So whenever you get migraine or headaches, you should understand your body needs water. Our body should have 70 to 72% water, but if you actually measure your water content, female would find themselves having 50 to 52%, male would be having around 60% water. But this is very low, very low compared to what our body needs. And that's the reason we get occasional headaches. We go into depression, hypertensions, arthritis, pains, and so many things. And obesity is also increasing every day. So what's the benefit of using hydrogen water? Because we can take hydrogen as infusion or mask, but then those are not that easy way to take. Easy administration is drinking water, because we need to drink water to stay alive. So rather than drinking normal water, tap water or bottled water, or so-called alkaline water, which can be made by dissolving sodium bicarbonate in water. Any water, you take a drain water, put sodium bicarbonate, becomes alkaline water. Doesn't make sense. It does not have negative ORP. The water which can give you negative ORP is the right water for us, and the research is heavily on this water now, because this water has been found to be beneficial against aging, against detoxification, against all gastroenterological problems, liver, kidney functions, all sorts of skin problems. Your immune system gets boosted up. And once your immune system gets boosted up, come COVID-19, COVID-20, COVID-21, your body has got that power to get rid of all these COVIDs. So don't bother about COVID-19 or COVID-20. Bother about what you are intaking, what you are supplying to your body. Are you giving the right thing to your body to keep your body recharged? No. If no, then all COVIDs can attack you. just heal up your immune system, recharge and boost your immune system. And that can only be done if we have enough hydrogen, because all answer lies in the first element of the periodic table. Dr. Corey Allen, he's one of the neuroscientists. She uses his ionized water a lot, and she found that 43% improved result on autism, on Alzheimer's, on dyslexia, learning disabilities. This is a man behind endoscopy. He's an inventor of endoscopy, Dr. Hiro Mishinya. He has actually done 300,000 operations of endoscopy. It's pretty old now, but still he's the chief of endoscopy at New York. He has got so many books. If you can get they are available in Amazon. So check Amazon and get these books if possible. You see, this is a colon before and after treatment with hydrogen-rich water. See, it's a chronic constipated colon of a 45-year-old woman. And then after treatment with water, see the colon condition. All the stools which were there have actually got washed away and regenerated colon. And colon is the place where all our good bacteria live. Now, if these good bacteria stay in our gut, our body would have a lot of strong immunity, and we can eat well, we can digest well, we can get more and more energy and can stay young. See the cancerous colon on the left, the black one, it's all colon cancer, very popular. The first popular cancer in America due to their diets. And this is the same colon after 3 months of treatment with chemotherapy as well as hydrogen-rich ionized water. So it's the more important part is, is a water. Whatever you eat, it has to get dissolved, and it has to get dissolved in water because the nutrition has to pass through blood, then only it would reach your cells. And the blood is composed of water, just like if in a fish in an aquarium. Now, think of our body as an aquarium, as a fish tank, and all our organs just like different fish. What happens if there is a problem with one fish? What do? You throw away the fish or you change the water? So you change the water. That's what we need to do. Rather than throwing away the kidney or colon or liver or heart, we rather change the water. Adding medicine, or since we are pharmacists, we deal with medicine. I'm a pharmacist, but I recommend minimum to minimum medicine. And believe me, in Australia, the Pharmaceutical Society of Australia, they recommend minimum medicine. Antibiotics are hardly been prescribed here. People only believe on nutraceuticals more rather than pharmaceuticals, because medicine has got two effects. First, the body would take time to get rid of the disease using the medicine, and then the body has to get rid of the medicine, because every medicine, every drug, every chemical has got some toxic effect on our body. So rather than giving medicine to that aquarium, which is our body, is our fish tank, change the water. So we need to focus on right water, because the 5 elements, one of the common element, air, water, fire, earth, and what else? What's the 5th one? That's a quiz. I want that answer to be coming on the chat box. So out of that, water is one of the key area, because 70% of our body is composed of water. And that's the reason in our grandfathers, fathers, they used to say, if you have some problem, go and change air and water. In Hindi, they used to say, hawa pani badal ke lao. So hum hawa badalne ke liye ja rahe hain, ya pani badalne ke liye ja rahe hain. So why we used to say that? Because hawa means air and pani means water, are key thing for our body. Our body gets healed up if we change this water and air. Right air, right water would actually change our body and heal us and recharge us, rather than, and we don't need any medicine for any other disease. Now, I could have talked hours and hours, but I can see it's pretty long. Anybody who is interested can check this website. The first website it's my personal website, and I'm also associated with the Molecular Hydrogen Institute of Japan. You can always go there and check the website of molecularhydrogeninstitute.com, and you'll find loads and loads of information and all the research papers on molecular hydrogen there. You would be shocked to see what a treasure of therapeutics lying in that small element called hydrogen. We don't need medicine. We need hydrogen. We need the right water. So change your water, change your life. Thank you. And I would expect certain questions in the chat box. And if somebody wants to speak, and if the organizer permits, they can go ahead and unmute them and allow them to ask some questions if they have. Thanks.
Thank you so much, sir, for your interesting and fascinating lecture on molecular hydrogen and its therapeutic benefit. It was indeed a very interesting topic, and yes, many of the topics it was very new to us. You have discussed so many unknown facts to us about molecular hydrogen, and really every one of us are very much benefited, and I can say every one of us has enriched their knowledge bank on molecular hydrogen. Thank you so much, sir, for your very informative lecture on this.
Thank
Now,
you, Arundhati.
thank you, sir. Now, I would like to request participants, if you have some questions and doubts, you can ask sir. Sir is with us. You can unmute yourself and ask, or you can write your question or doubts in the chat box. Yes, participants, you can write the question in the chat box.
Hydrogen, which water is there any what started in India?
I've shared my website on the chat box. If somebody wants to note it down, they can do that. Also, I'm sharing the Molecular Hydrogen Institute. .com.
Yes, participants, please raise your questions to sir.
It's been a long day, I can understand. And yeah, it's been evening there.
Yes, it's about to be 4 p.m. here.
Yeah, it's 8 p.m. here in Australia.
Okay, sir.
All right. Yeah,
Yes, sir. Got one question, sir.
yeah, I got a question from Choyonika.
Yes, sir.
Choyonika asks me, is there any research going on in India about molecular hydrogen? Yes, yes, yes. And these devices are also now available in India. So if you check the website, you'll get some Indian link. My website has got Indian link. Rijaul asks me, any hydrogen therapy or especially COVID-19 in India or any machine? Yes, there is a machine. That's what I'm saying. So check my website. The machines are there, and thousands of Indians are getting benefit out of it. I think everybody heard about Yuvraj Singh, the
Yes.
cricketer,
Yes, sir.
came back from cancer and started playing cricket again. He started drinking hydrogen-rich water, and that helped him to come back from cancer. Heard of Monisha Koirala, the famous film actress, came back from cancer from hydrogen-rich water after drinking. She had chemotherapy and everything, but also along with that, she constantly went on drinking hydrogen-rich water. All the film artists of India and Hollywood, or talk about anywhere, all the athletes, boxers, rugby players, soccer players, they use this water. Just you go to YouTube and type Kangen water. Kangen is the Japanese word they use, means back to origin. It's the only water, medicated water in the world. There are a lot of ionizer now available, but they are not medicated. Kangen is the only water which is it's a gold standard water by Water Quality Association. Uh, they don't advertise, that's why we don't know it. But go to Amitabh Bachchan's house, you will find two. Go to Bill Gates' house, you'll find 46 machine, 46 on in the entire Microsoft office and in his mansions. Uh, Go to anywhere, talk to the current president of America, Donald Trump, has got 12 Kangen water machines. So they use hydrogen water because they know the power of it. Talk to the NASA scientist. NASA endorses only one water, which is the hydrogen rich ionized Kangen water, uh, because they know the power of it. Uh, so definitely do some research. Go to molecularhydrogeninstitute.com website and see what sort of researches are going on. Anybody, any faculty member who is interested to do PhD can pick this topic, which is very easy topic, which you can take this water um, and and do a research on therapy. And I got a question again: if the use of RO water is not good for our health, then why are water purifier companies forced? Well, they buy on. RO is banned in Europe. RO is banned in USA, Canada. RO is one of the worst kind of water which you can think. RO, what it does is it takes away all the good minerals from the water. And the RO water's ORP, oxidative reductive potential, is positive. So the RO water actually oxidizes our body rather than reduces our body. And that's why RO water, and there is a notice recently came out by the Indian government. They said RO water, they're going to ban RO water. So no more Hema Malini advertisement going on with Kent and other things. So RO is going to get banned in India soon. So RO is no good. Don't ever drink RO. Don't spend money on RO water, please.
Sir, I have a question.
Yeah.
Yeah, sir, this hydrogen-rich water,
Mhm.
we can drink that directly like normal water, or there are some doses form like that to drink.
No. You can drink like normal water. So right now I'm drinking this. Uh,
Okay.
it's a hydrogen, full of hydrogen. The problem with this water, you can't store it in plastic bottles because plastics have got pores in them. Hydrogen being so small, they just fly out of these pores. Okay, so you can't bottle it and sell it if this is not sellable water. You can only drink from the machine,
Oh,
and it you can store it in a glass bottle, or you can store it in metal bottles, steel bottles. In steel and glass bottles, the hydrogen can stay for 48 hours to maximum 72 hours, uh, and you can get the benefit of it. But then the fresh hydrogen, I've shown you that glass
yes,
picture
sir.
where you get a cloud of hydrogen, infusion of hydrogen in water, which is amazingly good. It's so powerful antioxidant. The first glass of water in the morning can make your day um, full of energy and give you a lot of energy and make your day so much active.
Okay, sir. Thank you, sir, for clearing our doubts.
No
Sir,
worries. Yeah, welcome.
thank you. Thank you, sir. Sir,
Oh, I got another question coming up. Roop Shikha, she's asking where we can get this hydrogen-based water. Yes, you check my website, Roop Shikha, and also Molecular Hydrogen is a scientific website, so that won't endorse any device. But my website, which is, I think I've given it there in the chat box. Uh, it is, you check that website, or you just type Kangen, Kangen, and you get where you get that device. All right, it's available in India, and it's one of the it's a big science development in India, big development. People are getting a lot of benefits: skin, arthritis, diabetes, hypertension, cholesterol. People who used to take cholesterol medicines are are not taking medicines further. Diabetes have reduced the medicine dosage. uh, Kidney transplantation patient stopped transplanting. Kidney started functioning back. uh, those who have got baldness have started indication of new black hairs coming up at the age of 65. So it's miraculous action. Can Kangen water be boiled? Yes, you can boil Kangen water, but the hydrogen would fly away. You can heat it or warm it in microwave, but the hydrogen would go out. You can even, but still, if the hydrogen is not there, you can still get the benefit of alkaline water, because this water has got a pH of 9.5. So it is alkaline. It's constantly, our body is acidic. Our body, all cancer is due to acidity. Our bodies are slowly acidic, and acid leads to pain, acidosis. So alkaline water is the only solution, and alkaline in the alkalized state through electrolysis, not by adding alkaline material. uh, our body can go back to original state. So yes, Kangen water can be boiled. Yes, we could use Kangen water for cooking. In Japan, every 3 household you get one household they use Kangen water, and they use it for cooking. The restaurants, they use it. America, they use it. Most of the restaurants use it in America, and the food quality, the taste of food, they grow heaps. So just go to YouTube, just Google them. You'll find many things about it. It's not possible to say everything on a webinar, but then I've just touched the basics of it, like what hydrogen can do for us as a therapeutic element, and as a pharmacist, we should know that.
Yes, sir. So thank you very much for your valuable time, and obviously for offering us your bundle of knowledge today on this great day. We are very much grateful to you, sir. So please
Thank
be
you.
with us. So please be with us now. I would request Ms. Rupshika Malakar, Assistant Professor, NEFCOP Guwahati, to kindly deliver vote of thanks to Amitava Ghosh, sir.
Am I audible, ma'am?
Yes,
Yeah,
ma'am.
yeah.
You are. Yes, ma'am.
Crystal clear.
Okay. So thank you for the opportunity, ma'am. So myself, Rupsika Malakar, Assistant Professor from the College of NEF College, Guwahati. So on behalf of NEF College of Pharmacy, Guwahati, and NEF College of Nagaon, I would like to take this opportunity to extend a hearty vote of thanks to one of our honorable delegate, Professor Amitava Ghosh, sir. So your talk on molecular hydrogen and its therapeutic benefits was really insightful, and it was very informative. So thank you so much, sir, for sharing your valuable time and experiences with us. We're so grateful to have you, sir, on this day. Thank you so much, sir.
Thank you.
Over to
Thank you.
you,
It
ma'am.
was a great pleasure. Thanks to
Okay.
the management. Thanks to the principals of NEF College and NEF College of Pharmacy and NEF College of Pharmaceutical Education and Research. And thank you all listening to me for more than an hour now.
Thank you so much, sir.
Thank you.
Now, moving on, as we have reached towards the end of our session, now I would request Mr. Torajut Tekar, sir, Assistant Professor, NEF College of Pharmacy, Guwahati, to please deliver the summary of today's international webinar on transforming global health.
Good afternoon, everyone. Thank you, Arundhati ma'am. So finally, we have come to the end of our today's graceful day, World Health Pharmacist Day. And I think it's been nearly, we have passed 10 years with the celebration of this day. So today, we have started from the morning, nearly 10, where we all had the inauguration ceremony from our respected director, sir, Dr. Zakir Hussain, Followed by that, we have two welcome speech from the principals of both the institute, NEF College of Pharmacy, Guwahati, Dr. Raja Chakravarti sir, and from NEF College of Pharmaceutical Education Research, Dr. Devapratim Das Gupta. So I thank both of them from on behalf of everyone. Next, we are followed by the resourceful person, which we have among us three important resourceful person. So in the morning, we had the first session, which was started by Dr. Ashutosh Sharma sir, who is a well-known name in the field of biotechnology. So Ashutosh Sharma sir has emphasized on the medicinal as well as phytochemical benefits of various plant extracts and derivatives, how ancient African peoples have utilized, and they have to say nearly 5,000 plant extracts have been identified by them, where 80% of plants are having medicinal use. So it was still a challenge in our modern day to get the benefit of these plants as well as extract the important derivatives. Then he gave a talk on the necessity of phyto and plant extracts and the need of the hour to develop them with different botanical sources and classifications. And then finally, he emphasized on the development of herbal genomics and development of antiviral drugs. Followed by that, we have a lunch break. And after lunch break, we have another person from Andhra Pradesh, Dr. P. Ramalingam from Raipur Institute, where sir has actually given a talk more related to the pharmaceutical research opportunities and challenges which are often faced by students and teachers and different peoples. And here in India, what is the most requirement is that research is still not given high importance. So sir has emphasized mainly on the research and importance in pharmaceutical field, and also he has given us today the new taxonomy, which is called as Bloom's taxonomy, as well as the rationale required for finding the objective of our research, which was still in the learning stage of our development. And after that, when we came to the end of today's session, we have one of the most innovator among us, Dr. Amitava Ghosh sir, who started his career not from anywhere, but only from the Northeast, from this place only. This man has started his career, and today he has given us a new actually window about the molecular benefit of hydrogen and its therapeutic benefits. So in that, sir discussed about the hydrogen facts and its non-carcinogenic properties, with starting from the Big Bang theory of timeline. Then also sir emphasized on the multiple use of hydrogen in different fields, as well like oil, petroleum, energy sector. Then how hydrogen was first discovered in a nature medicine, which was having an impact factor of 32, and the researcher named Dr. Osawa et al., where sir has shown us the paper that hydrogen can be utilized as a therapeutic antioxidant by reducing cytotoxic radicals. And then sir showed us the different therapeutic opportunities of hydrogen in the growing science of pharmaceutical field with different disease models. Then at last, coming to the conclusion from the sir's session, what we have seen that hydrogen can be having a superior role in the coming generation over other antioxidants, as well as how different hydrogen formulations can be benefited. And then lastly, he has emphasized on the benefits of hydrogen-rich water, especially for cancer patients and also as well as for normal patients. So if we see that from today's day, we are having three different peoples with their three knowledge and important shares of the different life. They have given us three important lessons. So with that, I would like to conclude my part. And with regard to more knowledge and more of questions, if you people like to know, then you all can reach all of our resource persons who have provided their IDs as well as Twitter accounts and websites. So over to you, Arundhati ma'am. Thank you very much.
Thank you, Deka sir. With this, we have reached towards the end of today's international webinar. On behalf of the organizing committee, NEF College of Pharmacy, Guwahati, and NEF College of Pharmaceutical Education and Research, Nagaon, I would like to extend my sincere thanks to our three most prominent and wonderful resource person, Dr. Ashutosh Sharma, Dr. P. Ramalingam, and Dr. Amitava Ghosh sir, for being with us and sparing their valuable time from their busy schedule and delivering such an informative lecture series. I am sure we all have learned so much from today's webinar. I would also thank our director, sir, for gracing this international virtual event organized jointly by both the institution for the first time. Principals, Dr. Raja Chakraborty, sir, and Dr. Das Gupta, sir, for their continuous help and support all throughout the successful accomplishment of today's program. Thank you, sir. I would thank our organizing committee, Sajidul Ansari, sir, Assistant Professor, and EF College of Pharmacy, Guwahati, for all the background support and help, without which this webinar wouldn't have been possible to conduct. Last but not the least, and most importantly, I thank you all the participants. You have been really wonderful listeners, and our best wishes are always with you. Thank you. Now, I would request Dr. Raja Chakraborty, sir, to please mark the closing session of today's international webinar.
Thank you very much, Arundhati ma'am.
Thank you.
It's a wonderful day we had today. We have a spectacular of gathering of knowledge in different areas. I especially convey my thanks to all the resource person, Dr. Amitava Ghosh, Dr. Ashutosh Sharma, Dr. P. Ramalingam, to spend some time from their busy schedule to just convey their expertise and experience with our participants who are just learning in their learning. The maximum of them are in just learning stage and about to know about the pharmacy field. And definitely this day we are rightly celebrated as a World Pharmacists Day 2020. With these words, again I thank everyone, all the speakers, participants, organizers, teachers, for just making this event successful. With this, I just declare the closure of this session. Thank you very much. Over to Arundhati, just close it.
Thank you, everyone. So with this, we are closing and you can leave the program. Thank you. And the feedback link has been shared in the chat box, and please give us a time of 1 week so that we can deliver your certificates to your respective email IDs. Thank you.